Hey, it's Mr. Shrum, and I am back again with a tutorial walkthrough for physical science. And we're going to look at the differences between physical changes and chemical changes. And getting into the introduction. All right, you can chisel a baseball bat out of a piece of wood. The wood changes shape. You can burn a piece of wood in a fireplace. The wood turns to ash, which is also a change. How do you think those two changes differ? Well, for the first instance, you're changing the shape of wood, and the basic molecular structure of the wood hasn't changed at all. The wood stays the same, you're just shaping it differently. That is called a physical change. In the second instant, you're burning the wood. The molecular structure of the wood changed during the process of burning to ashes. That is a chemical change. So if you can differentiate between those two basic examples, then you're going to be able to figure out this lesson. And here's a short little quiz. Sugar dissolves in warm water. Is that physical or chemical? Male rusts. Okay, so sugar dissolving in warm water. Physical. Rust, that is a chemical change. Glass breaking, physical. A piece of paper burning, chemical. Iron and sulfur mix and form a partially magnetic black and yellow mixture. I'm gonna go with iron and sulfur are heated and form a non-metallic, oh, well, hold on. Maybe that's physical and that's chemical. So you have to think about what's actually going on. Dry ice, CO2, which is solid, is sublimed at room temperature. Vinegar reacts when mixing with baking soda, water boils. Zinc, when immersed in hydrochloric acid, produces hydrogen gas. So hold on. Well, that's a weird quiz. It doesn't show you all the answers. But anyway, moving on. How many questions did you answer correctly? Well, I saw I got the first 6 correct. And if you can see if you got the first 6 correct, then you're on your way to understanding. And if you still don't quite know what physical and chemical really means, or you can't tell the difference, maybe this will help. You may have noticed some key phrases such as change in molecular structure, new compound, new substance, changed state. Those are, in fact, the basic criteria that scientists consider for categorizing changes as either physical or chemical. So we can think of scientists as detectives, looking at evidence and taking that evidence and basing decisions on clues and prior knowledge. And they delve deeper to search for evidence that may not be apparent to you or me on the surface, right? You can only gain so much information by looking at something. Sometimes you need a closer look. So now we're going to look at the scientific evidence for the properties of physical and chemical properties. A property is a statement that describes certain attributes of something. How might you describe your best friend? He or she may be tall, short, shy, outgoing, quiet, or talkative, active, or lazy. Those are properties of a person. So you can think of a substance having certain properties that helps describe them. A piece of chalk is chemically known as calcium carbonate. The form of chalk used in art classes is soft, usually white, but it comes in other colors as well. You may have also used chalk on pool cues or in gym class to improve your grip on gym equipment. When heated, this calcium carbonate decomposes to form calcium oxide. And that's used to make cement and fertilizers and as a flux to remove oxidation in copper smelting. All of these characteristics or properties of chalk can be categorized as either physical or chemical. But what basis do we use to label a property as either physical or chemical? Physical. So the physical properties of a substance can be measured, observed, without altering its molecular structure. So one of the examples, and from the questions previously asked, you can measure the boiling point of water by heating it and using a thermometer to measure the temperature at which it begins to boil. In that case, you're not altering the water's molecular structure in any way. Physical properties of a substance include its state of matter, color, texture, melting point, boiling point, conductivity, malleability. The state of a substance can be described as the phase in which matter exists. This phase can be either solid, liquid, or gas. At room temperature, aluminum foil is in a solid state, whereas water is a liquid. The color and texture of a substance determines its external appearance. So for example, aluminum is a white colored metal, whereas water is a colorless and transparent substance. The physical properties of a substance also includes its melting point, boiling point, conductivity, and malleability. How much heat does it take to melt ice? Unless you are living in sub-zero temps, as soon as you take ice out of the freezer, it starts melting. Do other solids also melt so easily? Not generally. Most metals, for example, melt at very high temperatures. A melting point is the temperature at which a solid substance changes into its liquid phase. And a boiling point is the temperature at which a liquid begins to change into its gaseous phase. Solid water or ice melts into liquid water at temperatures above 32 degrees Fahrenheit, 0 degrees Celsius. Liquid water begins to boil at 212 degrees Fahrenheit and 100 degrees Celsius. Aluminum, on the other hand, melts at around 1,220 degrees Fahrenheit, or 660 degrees Celsius, and boils at 4,566 degrees Fahrenheit, or 2,467 degrees Celsius. So you can see that water compared to oil, or not oil, metal, water compared to metals boils at a very lower temperature, a much lower temperature compared to those metals. And the ability of a substance to conduct electricity is called conductivity. So you may have noticed that electric wires are never made of plastic, and pots and pans used for cooking are never made of wood. That's because metals are good conductors of heat and electricity, while wood and plastic are not. Similarly, substances such as metals can be beaten, shaped into thin sheets, where others, such as glass, break if you beat the glass. So, when a substance can be beaten or rolled, that is malleable. And that's another physical property. Chemical properties of a substance determine its ability to react with other substances. Any chemical reaction results in changes in the molecular structure of a substance. For example, iron reacts with oxygen in the atmosphere to form iron oxide or rust. This is a chemical property of iron. Chemical properties of a substance include its pH value and how it reacts with oxygen, water, acids, and bases. So we can explore some of these properties. The pH value of a substance determines whether it's acidic, basic, or neutral. The scale ranges from 1 to 14, Lower pH values indicate acidic properties. So if between 0 and 6, that is generally acidic. 7, that's pure water, neutral. And then higher pHs are basic. Reaction with oxygen, different substances react with oxygen in different ways. And sometimes they form corresponding oxides. When sodium is exposed to air, it spontaneously burns with an orange flame. That's because sodium reacts with the oxygen present in the air and forms sodium oxide. So in this example, we see how different substances react differently with water. Some, like marble, are barely affected. Others dissolve in water, undergoing a physical change. Some substances react chemically with water. For example, when potassium comes in contact with water, it forms potassium hydroxide. As you can see in the video, is a very highly explosive reaction in which hydrogen gas is released. So here we go. Whoa. So they just dropped it in, and once it comes into contact with the water, it starts to form that potassium hydroxide. And then you get to see that really explosive reaction. Another way to look at things, reaction with acids and bases. Another chemical property is the way it reacts with either of these strong acids or bases. For example, sodium undergoes a vigorous chemical reaction with an acid to form the corresponding sodium salt. When sodium reacts with hydrochloric acid, sodium chloride is formed and hydrogen gas is released. A similar reaction occurs when metal reacts with a base. So, for example, when zinc reacts with sodium hydroxide, sodium zincate is formed and hydrogen gas is released. Try these practice exercises to see if you understand the concepts of physical and chemical properties. You can do that on your own. I'll do these matching questions for you. All right, so we're gonna match the correct property to each example. Vinegar has a pH of 2. pH is a chemical property. Bromine boils at 59 degrees Celsius as a physical property. Baking soda is a white crystalline solid. That's the appearance of baking soda. Sodium catches fire when it's exposed to oxygen. It's a chemical property. Corn syrup has a density of 1.38 grams per milliliter. That's physical property. Iron rusts when it's exposed to moisture. Ta-da, cool. All right, so I'll stop there for now, and we'll come back to finish this tutorial a little later. So I will see you then. Bye-bye.